Hi, welcome to my video on explaining the number of times you're doing a derivative on a composite function. Find y prime. Number one, y prime, if it's not composite, then you have only one derivative. So this is y equals x to the sixth. So the derivative is y prime is the derivative of a y. Remember, y prime is dy dx. That means you do the derivative of y in terms of x. So that becomes the power of 6. 1 times 6 is 6, and 6 minus 1 is 5. So when it's not composite, just a plain function in terms of x, we have one derivative to do. So what about if we have the composition of two functions? So if we have the composition of two functions, we'll do it twice, or we'll do the derivative 2 times. And let's explain. So if we have this function y equals bracket 2x minus 7 to the 6th power. So notice I kept y to the 6, x to the 6th. So now I put another function inside of here as a composite of x to the 6th. So if the f of x is equal to x to the 6th, and the g of x is 2x plus 7. So this is f of g of x, so it's a composite function. So the g of x is going in the place of x right here, so that x is being replaced by 2x plus 7. So the derivative is, it's a composite function. Again, we're going to use the chain rule. So what happens? We get the power rule. So we'll do the derivative of the main function. Again, we treat 2x plus 7 as if it was an x. So we're doing the derivative, and we have to go with the function that's inside. So we work outside, inside. So the outside is power of 6, the inside is 2x plus 7. So we do two derivatives, y prime. So the derivative here is going to be, in terms of the x to the 6th, is 6 times 2x plus 7 to the 5th power. Very similar to here. Same thing, only that now instead of an x, we have 2x plus 7. And the derivative of the inside, which is 2x plus 7, derivative of 2x is 2, derivative of 7 is 0. So we get y prime is 12, 2x plus 7 to the 5th power. Again, there's two functions, so the derivative is twice. Once for the outside one and once for the inside one. What about the composition of three functions? So that means we're going to have to do the derivative 3 times. So let's check this out. So y equals the sine to the 6th power. So that can be written as 2x plus 7. And this is sine to the 6th power. So we also can think about it's the whole function raised to the 6th power, because this power of sine here can be written outside. So we have the f of x, and we have a g of x, and we have an h of x. So we have, same as before, x to the 6th, but this time we have sine x is the g, and the inside is 2x plus 7. So when you do the composite function, you get the f of the g of the h. So notice 1, 2, 3 brackets here, so there's 3 at the end. So the h is going into g, which is then, that's going into f. So there's 3 functions. So we do y prime. We do the derivative of this inside, or the derivative of the 6th power. So again, the same as before. It's the derivative of the 6th power. So it's all raised to the 6th power. And we're doing a derivative of that times the derivative of the inside, which is sine, so that's sine 6x plus 7, derivative of that. There's a small bracket, that's a 7, so this is the small bracket on the angle here. So this is the derivative of all of it, and plus the derivative of the inside of this is 2x. So notice the outside is the 6th power, then it's the sine, and then it's the binomial. So there's 3 parts. 1, 2, 3. So you do the derivative of the x to the 6th, you do the derivative of the sine, and you do the derivative of 2x plus 7. So it's 3 of them. So that's derivative of this 6th power, so it's 6 sine 2x plus 7, and that's raised to the 5th power. The power 6 goes in front, 6 times 1 is 6, and 6 becomes a 5. Derivative of sine is cos, and it's the cos of that angle. And the derivative of 2x plus 7 is just 2. Derivative of 2x is 2, derivative of 7 is 0. So that becomes y prime, so 2 times 6 is 12. And we write this a little bit different if we want. Instead of the 5th power, we can go sine 5th power of 2x plus 7 cos 2x plus 7. So this is understood to be a multiplication right here. So that's the derivative. Again, there's 3 functions, so there's 3 derivatives. You work outside in. Again, you do the 6th power, you do the sine, and you do the derivative of the binomial. And let's continue. So thought I might explain the different ways, or not the different ways, but how many derivatives you do depending on the composite function, how many. So what about if we look at the composition of 4 functions? So let's see 4 functions. We'll say that's 4 times. So let's look at, we have this function, so y equals, that's the sine 3 2x plus 7, and this is raised, again I do this raised to the 6th power, even though I know that sine to the 6th is all of this function raised to the 6th power. I'm illustrating that we do the 6th power first. So this function is f of x is x to the 6th. The g of x, same as before, is sine x. But this time we have the h of x is, notice we have 3 raised to this power, so that's 3 to the x. And we have, say, the j of x is 2x plus 7. So that gives us, again, the f of the g, of the h, of the j, and we got of x, and there's 2, 3, 4. So the j of x goes in the h, and then that goes into g, and that goes in the h. So we work outside in. So therefore, y prime, which is d dx or dy dx, we do d dx on the y, which gives us this, and we do d dx here. So we take the whole function, and we get s derivative, or the sine 3 2 to the x 7. So there it is. So the derivative of this, so it's the derivative of what we have here, and the derivative of the inside, which is sine 3 2x plus 7 derivative, and then we got this, so it's a sine. Now we have the derivative of 3 to the 2x plus 7, which is the exponential, and then we have the derivative of 2x plus 7. So think about this as x to the 6th, think about this as sine to the x, think about this as 3 to the x, and this is 2x plus 7. So again, they're composite functions, so they're going into each other. So you can see what I'm doing here. And we do the derivative of each one. So the derivative of the sine is 6. And we have sine 3 to 2x plus 7. And the 6 becomes 5. Derivative of sine is cos. So it's cos 3 to the 2x plus 7. And we get the derivative of e to the 2x. Oop, I forgot to put the derivative there and the derivative there. So it's 1, 2, 3, 4 derivatives. But I forgot to put that derivative in. So e to the 2x plus 7 becomes, that's 3 to the 2x plus 7 times ln 3. And this one, derivative of 2x is 2, derivative of 7 is 0. So this time we have y prime is 2 times 6 is 12. And we have to write all these down as they are. So we can go sine as the power of 5, so we put the 5 here. And this is cos. And this is 3 to the 2x plus 7, and that's ln 3, and the 2 is gone times the 6. So again, showing you that there's 4 functions, so there's 4 derivatives. Again, working outside in when we do the derivative on the composite function using the chain rule. And if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.